morning students. Last class we have seen the topic of distillation, fractional distillation. Okay, distillation, we have seen the condition for distillation, 3 conditions. What is that? Can you remember? Yes. The first one is the boiling point. Okay, first it should be miscible. 2 liquids should be miscible. Second one, it should not decompose. The boiling substance should not decompose. Third one, what we have seen is the difference in the boiling point at least should be 25 degrees Celsius. That we have seen. And what is distillation? 2 processes takes place: evaporation, condensation. Then we have seen distillation, fractional distillation. Distillation 2 solutions, fractional distillation more than 2 solutions, and it can have a difference in the boiling point, even very less. Everything we have seen. Extra one fractionating column will be in the fractional distillation. Twice the condensation takes place. All those things we have seen in the last class. Today we are going to see how to separate gases from air. Air contains what are the things? Air contains major nitrogen. Okay, it is around 78%. Okay, 78.1%, and nearly 20.9% of oxygen, and remaining is inert gases as well as dust particles, carbon dioxide, meager percentage is there. So we can even separate gases from air. So we are going to see how the air. Okay, now first how the separation of gases from air we are going to see. The air, okay, contain these gases. So I have to separate from that oxygen, argon, nitrogen. It is all present in air. So air is a gaseous state. Okay, in order to convert the gas into liquid, what we will do? We will give pressure. Okay, we will be giving pressure. And what we have to do? We have to reduce the temperature. It happens when it is cooled. So air, okay, it is compressed. It means what? We are cooling it at high pressure. Next, and the temperature should be reduced. This aroma says that increase in pressure. What we have to do? We are increasing the pressure so that the molecules become closer. So increasing the pressure, and what I will be doing? This downward arrow mark says that decrease. We have to decrease the temperature of the air so that it becomes what? Liquid air. And the liquid air is allowed to warm up slowly. And what happens then? It will be separated in a fractionating column. See, fractionating column is what? Nothing but different liquids have different boiling points and different height they will be. If it has a high boiling point, it will be down. So according to the boiling point, they will be there, and from that outlets will be there. In that height, we can separate different fractions of liquids, gas. Okay, so that column it undergoes fractional distillation column, and then we can separate it according to their height. Okay, so we are going to see that first what you have to do, no, the same it is given in the diagram. You can see that first the air should be filtered. The air will be filtered by a filter. Okay, that filter will filter the dust particle. After that, the air will be free from dust particle. After that, what happens? We are giving high pressure and reducing the temperature. So hot air will be there. So when the air is filtered, after that it is given high pressure. Air is given high pressure. After that, what happens? It is warmed. So the hot air will be passing. You know one thing, carbon dioxide will not become liquefied. Okay, they are directly goes to the gas to solid. So what happens? A separator is there. So carbon dioxide will be separated from the separator because it will not go to the liquid state. So in the air, carbon dioxide is separated. and from that what goes there is oxygen, argon and nitrogen. Oxygen is minus 183 is the boiling point. So the liquid air will be going to the fractionating column. The liquid oxygen will be settling down because it is denser. Okay, the boiling point is this. So it will be in the lower range. After that you will be seeing the argon. After that you will be seeing the outlet of nitrogen. So you can see the picture in your book as well as I will show you here. So what is the first one? It is filtered, then it is warmed and then it is cooled in the condenser where the freeze water is sent, cold water is sent so that it will be cooled, and while cooling carbon dioxide will not become liquid. So it is separated. After that what happens? It will go in a liquid stage. That air will be going to the fractionating column. What will be obtained at the lowest? Oxygen. Then you will get argon, then nitrogen. This way we can separate gases from air. Okay, can you all understand this? Yes. Shall we go for the next? So this way the gases, okay, it is present in the atmosphere, can be separated and it can be used. Okay. Then what is crystallization? Okay. Evaporation means what? The volatile substance can be separated from non-volatile. Okay. A crystallization also you will be getting pure form of solid. But comparing to evaporation, crystallization is good. Why? How far? When the sugar is separated from the salt water. Okay, sugar is separated from sugar solution. What happens to the sugar when you are going on heating? The water will be evaporated. What happened to the sugar? The sugar becomes charred when you are heating more. So, in order to avoid the decomposition and the wasting of material, crystallization is far better than the evaporation. And the impurities may even contaminate in the evaporation, but crystallization, the contamination will not take place. The impurities will be removed by the supernatant liquid. Okay. What is crystallization first? You have studied in your lower class that copper sulfate salt, when it is mixed with, okay, I will be taking a beaker. Okay, in that tripod stand, I will be heating the. First, I will mix water. I will take water. In that, I will be adding copper sulfate. Okay, I will be adding copper sulfate. How much it can dissolve? I will dissolve. After that, what I will do? I will be heating it. When the temperature increases, solubility also increases. Again, I can add some more solute. That is copper sulfate to water. Okay. Then what happens? It becomes saturated solution. You know that when temperature increases, solubility increases, some more copper sulfate can dissolve. So it dissolves and it is soluble more than that what we have in the cold condition. So hot water, copper sulfate is added, and what happened? It becomes saturated. I will be heating. After that, I will cool it. When I am cooling, in the sunlight I can cool it. The water will evaporate. The copper sulfate crystal will be there. If the sunlight is not there, what we can do? We can cool it. Okay, we can filter it. While filtering, the supernatant, the clear solution, it comes out, and the copper sulfate crystal. Okay, you can get it. Or we can decant it. What is decantation? The liquid will be there. First we can pour it. The impurities also will come along with the liquid. Only the copper sulfate crystal will be obtained. So on heating, after that I will be cooling. Like distillation, here also two things happen. Heating and cooling. After that I will be getting pure solid form. It is far better than evaporation. Okay? Yes. So crystallization, why it is far better? First, it will not decompose. Okay? Impurities will not be there. Okay? Then that charring, wastage of solute, what we need will not take place. That is, crystallization is having advantage over evaporation. The 2 points are there in your book, you can go through. Then shall we go for the purification of water? Yes. You have ever seen the dam water? You have seen and you have gone to visit. You have visited dam. You can see that the water reservoirs, they will be storing the water, and one side you can see it will be for purification of drinking water. One side it will be left for purification of water for domestic purpose. Okay. When you see one side, the water will be flowing from the reservoir, from the dam. Okay, and it reaches first. It will reach bigger particles of stones will be there. Okay. After that, when you see, gravels will be there, small size. Why it is like this? Have you ever think about it? After that, just small particles of stones with the gravel will be. After that, fine sand will be there. Okay. What purpose it is there? When the water is poured with force, what happens? The bigger particles, okay, will settle in the first stage. You have studied in water sewage treatment, all these things, no? That is same only here. First, the larger particles will be, coarser particles will be stored in the bigger stones. After that, some particles will be there, no? That will be stored in the next stage. After that, what happens? Fine sand with gravel. The fine sand, all the dust particles will settle here. Only the water will be coming out. But even though it may have some germs in that, for that what we will do? We can purify by using chlorine, okay, alum. Alum is picri, they will be saying. It is potassium sulfate and potassium sulfate and aluminum sulfate, double salt. So these chlorine and alum is used for killing the germs. It is disinfectant and it purifies the water. It kills the germs. So chlorination is done after this, and then it is led to the hole. So from the reservoir, it goes to the tank which contains these things, and then the water comes, and even the small organisms, okay, it is killed by purifying it with chlorine or alum. After that, it is led into the domestic purpose. For each house it comes. So this is the way the water is purified. It's very easy, no? Can we have a recapitulation? Yes. First, what we have seen? How can we separate gases from air? Air is compressed at high pressure and low temperature. It becomes liquid air, and then it goes to the fractionating column, and then last what will come? You will be getting the gases in different height, so that you can separate it. Crystallization is far better than evaporation. Okay, it will not decompose, impurities will not be there, and then it will not be charred or wasted. So crystallization, what happens? We will be heating the saturated solution. After that cooling, we will be getting the crystals. Purification, what happens? The water, it is let in the reservoirs. After that, it goes to the tank which contains these things. Okay, the coarser particles will be settling there. You will be getting pure water which has some bacteria that will be killed by purification. And then what happens? We will be getting the water. So these three methods, please go through. It is very easy. Thank you.